Hi, my name is Andrea Neiman, and today we are going to calculate the inverse of 2 plus 4i minus 2j plus 3k. In order to calculate this, we need to know what quaternions are. Quaternionic numbers are numbers of the form w plus xi plus yj plus zk, where w, x, y, and z could be any real number, and I, j, and k are three imaginary axes. Now that we know what a quaternion is, in the form of w plus xi plus yj plus zk, then we can set it equal to a variable, capital H. Based on the definition, if w, x, y, and z can be any real number, then h can be equal to 1 plus 5i plus 9j plus 2k, for example. Going back to our example, we know that h equals 2 plus 4i minus 2j plus 3k. The formula to solve for the inverse quaternion is equal to the conjugate of a quaternion over the square norm. To start, we know that capital H is 2 plus 4i minus 2j plus 3k. So we can determine that the conjugate is 2 minus 4i plus 2j minus 3k. We just found the conjugate as the numerator. So now we have to find the square norm for the denominator. The square norm of a quaternion is capital H times the conjugate of h. This also equals to w squared plus x squared plus y squared plus z squared. Based on the initial definition of a quaternion, we know that w, x, y, and z are real numbers. So when solving the square norm, the answer is going to be a real number. We can see here that w equals 2, x equals 4, y is negative 2, and z is 3. As we solve for the square norm, we are going to plug in the values for w, x, y, and z. We know that 2 squared is 4, plus 4 squared, which is 16, plus negative 2 squared, which equals 4, and then we get 3 squared, which is 9, and we add everything up. When we solve that, we get 4 plus 16 plus 4 plus 9. Now, all we have to do is add everything. Adding from left to right, we get 20 plus 4 plus 9, which also equals to 24 plus 9, and our final answer is 33 when we add 24 plus 9. Therefore, the square norm is 33. Now that we know what the conjugate and the square norm are, we are ready to solve for the inverse quaternion by plugging our answers into the formula. Let's recall that the inverse quaternion is equal to the conjugate over the squared norm, where the conjugate equals 2 minus 4i plus 2j minus 3k, and the square norm is 33. Now we can calculate the inverse. Here we have 2 minus 4i plus 2j minus 3k over 33. We can separate them individually as 2 over 33 minus 4i over 33 plus 2j over 33 minus 3k over 33. And we do this so that when we simplify, that becomes easier. For the final steps, we can see that 2 over 33 can't be simplified anymore. 4 over 33i can't be simplified either. 2 over 33j can't be simplified either. However, negative 3 over 33k can be simplified. Our final answer would be 2 over 33 minus 4 over 33i plus 2 over 33j minus 1 over 11k. So we calculated the inverse of h, and that concludes our video. Thank you.